So, good afternoon, everybody. Myself, Acharya Vishvendra, and today I shall be speaking on the polytropic process. I'll discuss a worksheet based on that. So, let's begin with the worksheet. Here is the worksheet. So, worksheet on polytropic process. So, let's begin with the first question. It is a gas undergoes a process PV raised to power n is constant, which is given by this equation. N is. So, as we can see that on increasing volume, pressure decreases. So, that means N has to be positive, because if N is negative, then pressure will be proportional to V square. So it will increase with increase in volume, but since it is decreasing with volume, that means N has to be positive over here. Next is P1 by P2. So substituting in the equation, it is V2 by V1 raised to power n. Next is Vt relation. So we know that PV n constant. Substituting P is nRT by V into V raised to power n constant. So we can see that here T V raised to power n minus 1 will be constant. Next is Pt relation. So substituting V, we have P raised to power 1 minus n, T raised to power n constant. Here taking the 1 minus nth root, so that will be P raised to power n upon 1 minus n is equal to constant. Next is Pt graph. So there are two cases. If n is less than 0 and greater than 1, then you can see over here that on increasing temperature, pressure will increase. Whereas if n lies between 0 and 1, so that thing will be positive. So that means it will decrease with temperature. So two possibilities are there. Next is Vt graph. So as you can see, Vt relation is this. So if n is greater than 1, then this thing will be positive. That means T will decrease with n V or vice versa. And if